The title of my presentation is Repeating Earthquakes Partially Reload Themselves in Parkfield. This is work done by myself, Colin Pennington, Kayla Kroll, and Bill Ellsworth. And what we're doing here is trying to understand some repeating earthquake observations that we made a number of years ago. And those observations were that we saw a slip predictable sense scaling. And so what we're looking at is a number of different repeating earthquake sequences with moment plotted as a function of recurrence time, or the amount of time since the previous earthquake. And you can see for these sequences, the magnitude does appear to get larger as the time since the previous event increases. Now, this is a slip predictable sense scaling, but this is not perfectly slip predictable. And what I mean by perfectly slip predictable is that in a perfectly slip predictable world, at time equals 0, there should be no moment available. But what you can clearly see is in this perfectly slip predictable line, you'd have 0 moment, but all of these are projecting back to a moment far greater than 0. So we're trying to understand what's happening here. And so what we think is really happening is that we have a nonlinear loading rate, like shown here in blue. Basically, you load very, very rapidly and tail off to a tectonic loading rate. But the problem is that we only have observations in this pink area. We're only looking at long recurrence time, sort of in an area where we're already back to the tectonic loading rate. And so if we were to fit a line to our observations, we would plot back to this point. So what we think is actually happening is a two-step process. First, we think we have a rupture on our asperity, or a rupture on our repeating earthquake, and that's going to cause afterslip in the area outside of our asperity. This is going to have a nonlinear loading rate. And the relaxation of this creep is actually going to reload the fault. And so this is what this would look like, the stressing rate on the fault would look like, and it's in exactly this nonlinear loading rate. If you want to see more details, please take a look at my poster.